So, welcome everybody. This is our live stream about evaluation and how to take our application to production. And in this session, I have two amazing speakers. I have first, our speaker will be Shahul. He is a co-founder of RAGAS. I started learning about evaluation, and RAGAS has been really helpful for me. So I'm super excited about Shahul's talk today. He'll discuss how to use AI to automate the boring parts of evaluation and various methods for utilizing user feedback as a part of your evaluation stack. And also he'll share the roadmap of RAGAS with you. Then Atita is going to be the second speaker of the day. We met in Berlin at the Haystack meetup last month, so I'm thrilled to host her today again. She is a solution architect at Qdrant, and she'll talk about RAG evaluation in action, tackling challenges and optimizing RAG with Qdrant and RAGAS. So two technicalities about the session. The session is recorded and it will be available on YouTube. And after the session, I will be sending an email to you with all the materials and the recording link. And you are free to use the Zoom's Q&A section for your questions. After every talk, I will be asking your questions to our speakers. So feel free to type your questions there. Without further ado, I think I can hand over to Shahul and you can start sharing your screen.
Hi guys, thanks for joining, and today we'll be discussing with about evals and how we can integrate automated evals and user feedback to improve your LLM application. So let me share my screen. Before that, I hope the screen is visible to everyone. Can someone confirm? Yeah. Okay. Yeah. Cool. Just yeah. So here mainly two things. I'll be discussing the high level details of RAGAS and what we stand for, and also some regarding some of the coming features, including the ability to use user feedback from production as a part of your evaluation stack. So let's get on with that. Okay, the first thing, evaluation is important. It's something that everyone talks these days. Everyone knows it's important, but just that nobody really has cracked how to do this evaluation in a scalable manner. So why we need evaluations basically ensures quality, helps you to improve the performance of your application, and also help you to avoid being in a situation like shooting in the dark situation with your AI application. So that's the three main pillars when we come to why evaluation is important at to adapt and use LLM application in production when it comes to enterprises. And now the next thing, manual evaluation is not really a fun job to do. If you are a developer or a part of a team developing an LLM application in production, you will have to evaluate the application because evaluation is important. And one way to do it is, of course, do some kind of manual evaluation, go through all these traces, figure out the best application and everything. But then, it's a very boring thing to do. Developers, really don't want to do it. It's not a scalable thing to do because once you have scaled your application beyond a point, you really can't go through all these traces and figure out what went wrong and what went right. And the whole thing of manual evaluation is that if you have someone else or annotators or someone to help you with it, it is very cost and time intensive process. You cannot really rely on a human or another person to do it for you, because there will be a lot of parts in it where it creates a lot of subjective opinions that rather than objective methods and matrices. So we need some way to move from manual evaluation, and that's where Ragas comes in. And what we stand for is to develop open source evaluation workflows that help as kind of co-pilots for you when it comes to evaluating LLM application. So here it is the core idea of Ragas is to develop these workflows that help you to automate 90% of the work when it comes to evaluation. For example, some of the features that we have in this are matrices and synthetic text data generation, which is currently in live in Ragas, and we'll be talking about feedback utilization. Taking just the example of synthetic text data generation. Okay, now to evaluate any RAG system, you need test data points. You need questions and ground truth answers. And if you do not have it, a way to get it is to annotate it manually, go through it by your own, spend all that time and boring job, and get that synthetic data, get that manual data annotated. Or you could make use of LLMs to create high quality synthetic data, which requires some work, which is the heavy lifting that Ragas does. And then your job is basically now the 10% of the work, which is just to go through the synthetically generated data and make sure that it has the data points that you need. Or if you see any data point that you do not need, you could just remove it from your generated set of data set. And this process is very scalable and can be done with minimal time and cost. And that's why these are the kind of workflows and the methods that we introduce to basically automate the 90% of the evaluation needs that we have today. And the core topic of this talk will be feedback utilization, as mentioned in the title. And what is basically feedback utilization? Once okay, now you have offline evaluation. Basically, it can be a combination of matrices and synthetic or manual test data, and you have basically analyzed your workflow, your LLM application offline while developing, and now you have something in production for the first time, or you are just kind of iterating your LLM application. Okay, once your application is out in production, it actually collects a lot of data that is valuable from production through user interactions, and this user interactions will yield you some kind of feedback data, which can be explicit or implicit, which we'll talk in the next slides. And the idea of feedback utilization is to add feedback data as a part of this evaluation stack and help you derive insights from production data, and also do error analysis from the same data, and also help you understand what does it means user satisfaction actually means for your own application. So these are the high level points that we will that the goals that we want to achieve using feedback utilization. And next, we'll talk a bit more about the nature of feedback itself. User feedbacks from production can be itself from two types. First type is implicit feedbacks, and the next type is explicit feedback. So explicit feedbacks, everyone knows, it's basically once you have your application in production, you will get some sort of input from users, which can be less than 1%. For example, let's say you have a conversational agent, like a RAG agent in production. Some of the users will at least leave some thumbs up and thumbs down feedback when they see some bad answers or good answers or something. These are basically explicit feedbacks. These are intentional feedbacks given by you by the user. Can be mainly these kind of discrete ratings or binary feedbacks, or in the form of free form text, which is basically user also explaining some issues behind the generated answer by the RAG system. This is basically explicit feedback, but the problem of explicit feedbacks, they are not they are basically less than 1% of the entire production load. For example, let's say you have 1,000 requests coming in, you will have maximum 10, thumbs up or thumbs down feedback in your system. Users do not have much reward for providing such explicit feedbacks, so they don't really do it, even though they are kind of annoyed with your application. Another nature of these explicit feedback is that there will be very skewed towards negative feedbacks. That is, users are more likely to provide you with a thumbs down signal than a thumbs up signal, because users care about when the system goes wrong more than when the system goes when the system performs well. So that's the basic nature of explicit feedbacks. Then comes implicit feedbacks. Implicit feedbacks are unintentional footprints that are left by the user when interacting with your RAG application. For example, if your app in your RAG application, if the user copy pastes the results, that means some level of satisfaction. And then there are signals like stopping the generation in between. If a user asks a question and the generation is coming up, and if the user stops the generation in between, that means that there is something wrong with that particular understanding of the user needs. And there can be all these implicit signals that you can observe in your application production, and that they also follow significant pattern. Now, next, one of the core nature of these feedbacks can be very noisy. All these user footprints, all these interactions with the users, everything comes very noisy. Nobody really knows or controls the user's behavior. So user might ask a question and he might get a good answer, but that answer might have come like couple of microseconds late due to the latency of the LLM itself, and the user might be annoyed because of that. You don't really have much to do there, but the user will leave a negative feedback. And then there are a lot of users who are basically trolls, and their basic nature is to give trolls like feedbacks to any application. And there are also all these other noisy feedbacks coming in, because it's in production, it's an uncontrolled environment, unlike where you annotate, where you pay your annotators and collect data. Users are not really paid to annotate or give feedbacks for you. They just expect your application to perform well because they are paying for your thing. So we need some kind of denoising in this to clean up this user feedback data before we are able to get any form of insight from it. And when it comes to denoising user feedback, there can be two levels in it. The first level is sample level feedback, which is basically for each sample you do some analysis, you do some kind of predictive modeling and measure the level of uncertainty or noise in it, and then you can either keep it or modify it based on your analysis. A second level of denoising can be user level feedback. Okay, now user level feedbacks are a little more interesting and can be applied to several applications where there exists a user ID. Now, with user level feedbacks, your goal is to identify those users or can be are or those can be termed as trolls that constantly gives you bad or adversarial feedbacks. So how do you do it? Basically, there are basic principles in doing it. You can do sample level analysis and then use the sample level analysis to aggregate based on user IDs. And if you see a certain percentage of noise coming from a particular user, you can have a threshold and you can just remove that user as a troll user. For example, let's say you have identified 5 of the 10 feedback given by a particular user as adversarial or troll kind. Then you can and if you have set your threshold to 50%, then this user would be categorized as a troll user, and none of the basic idea is that none of the feedback from this user will be taken into account again, because he gives a lot of he or she gives a lot of adversarial feedbacks. There could be also a combination of both these things, that is a sample level plus user level feedback. That is basically a kind of weightage or function that says that, okay, the score of the trustworthiness score of each feedback will be a combination of the trustworthiness of that particular feedback plus the trustworthiness of that user. So it is basically, then it becomes a weighted average of two coefficients, and user level and sample level becomes a part of it. And this is one of the techniques that has been effectively worked upon with several of our enterprise users. And this is a very interesting approach because for users, for applications that can actually track these user IDs, they are actually very helpful. Um, Now we're moving on to the next thing, which is basically augmenting user interactions. So now, now we talked a little bit of on what are the feedback steps and how we can basically denoise the user interactions. Now, the idea here is behind augmenting user interaction is to use LLMs itself to track and to track these user interactions. For example, let's say you have this RAG application, which is also a chat application. You'll basically have all these traces where user is asking questions and LLM is answering, and also user is asking follow-up question, and all these multi-chat thing going on. And this data can be actually augmented to understand, to derive more insight about the conversation itself, and also the satisfaction of the user. For example, a simple thing can be sentiment analysis to understand the final sentiment behind each conversation. Then there can be easy things like topic modeling to understand what are the high level topics that each user is very interested in conversing about. Then there can be lower level details such as analyzing user responses to derive satisfaction. What does that mean? Basically, let's say I have a multi-chat application in production, and I have a trace of this particular user chatting with uh, the RAG application, the RAG application. Okay, now if I have such behaviors, like if I have a question and LLM comes up with an answer, and if I ask that question again, or if I make some tweaks to that question and ask it again, that does mean that the first time I asked the question, there was some misalignment between the LLM's answer and my expectations. So these kind of very latent features, implicit signals can be actually derived from user interactions via LLMs, using LLMs itself for analyzing. And these interactions can be later effectively used for two things. First thing, to analyze the whole application itself. What is the basic action that the user takes when the whole application is going wrong? Is the user just leaving the application, or is the user trying to correct the LLM? All these kind of behaviors from users can be analyzed in depth to understand the performance of the application, and also the type of interactions that your users are having with your application. Then actually, then we'll discuss in the next part on how we can actually make use of all these explicit, implicit feedbacks, and also the data that we augmented from user interactions using LLMs. Now, you can actually model for user satisfaction, which effectively means predicting user satisfaction or user ratings for the the traces or the questions or the interactions that the user did not leave a user leave user feedback. For example, there can be the percentage of the user satisfaction ratings that user gives is basically less than 1% for most of the application, and then the 99% of data does not have this satisfaction rating. The idea here is using this 1% of the data, we can augment the data and then denoise and augment the data and train a model using this data to predict the user satisfaction for the 99% of the data that you have, and use that as a metric when you are also moving your application or developing your application, or to know the performance or user satisfaction in production. So how can we do it? Basically, you can model, one of the simplest method that we have seen is to model user satisfaction as a function of automated matrices. For example, you can run RAGAS matrices through many of the production traces. that have user feedback and collect that as again features, and then also have LLM augment some of the implicit features that comes with the user interaction and model user satisfaction as a function of both of these features. Basically, the idea is collect user feedbacks, which are thumbs up, thumbs down, run automated matrices, augment data, collect these features, now use user satisfaction as dependent variable, and the automated matrix and implicit features as independent variable, and basically train a simple machine learning model to learn that function. And by this, you can actually predict user feedbacks for your, for the data that you don't really have user feedbacks from users. So that's, some of the things that we can do. That's something which a lot of people are exploring. And then basically I'm just pointing out some of the challenges in doing everything. Basically, as I said, the explicit feedbacks from user can be very confusing, and from that also the basic feedbacks left by user is less than 1%, which is very less amount of data. And since this data also is also very skewed towards negative feedbacks, it becomes very hard to draw any statistically relevant significant conclusions from it. Then there is also noise in the data that we have covered earlier. And then there is a lack of workflows to enable these kind of insight gathering from user interactions, because the whole Gen AI thing is very new, and all this RAG and everything becoming in production is also very new. This problem is also very new, and the nature of the problem itself is very much unknown, because not many people have a lot of RAG application that scales up to maybe like 1,000 or 2,000 requests per day, and this itself creates a very big gap between the industry's requirements and also the research that's happening in this field, because this problem itself contains a lot of sub problems, and a lot of research and work needs to happen in this particular thing, so that people can use these data to actually understand the nature of and performance of their application in production. So that's about the my main topic regarding user feedback utilization. I would love to hear your thoughts on it. Up next, I'm just sharing some of the roadmap that Ragas has for the next 3 months, which we also release the same thing in our GitHub early next week. This is just basically an early bird's eye view. Regarding matrices, we are trying to increase the coverage of matrices to more data types and tasks. Currently, we do not support code and SQL kind of rack matrices. We'll try and include that in the next coming weeks. And also, automated matrices has trustability issues with developer, and we are trying to overcome it with some kind of human input to automated matrices. The workflow will look like something like this. For example, you could use automated matrices for some 20-30 initial samples. Make sure that it aligns to what you believe is the ground truth, or what you believe is a metric should be, and then using your interaction, Ragas or this whole automated metric thing should automatically optimize for your needs. That's something which we are working on. We would more where the entire goal is to win back the trust of the developer with automated matrices. Then comes synthetic test data generation. It's one of the highly used feature of Ragas. And with next feature, we are basically trying to increase the configurability of the whole thing, and also the ability to seed production data. All these test data generation, everything is worth a lot more when you can bring in 100 questions from production and extrapolate those questions from your existing data sets. That's what we are trying to do there. And feedback utilization is also something which we are working on. Basically, two things: denoising user feedbacks and error pattern analysis, where you can use Ragas to plug in your feedback and understand where the big clouds of errors or faults are happening in your LLM application. So yeah, that's it from me. Check out Ragas. I'll share the link to the slide here, and also we can share you to and join your Discord. You can also find me on Twitter if you have any doubts or something. I would be happy to help.
Thanks, Shahul, for the presentation. It was very interesting, and I already have some questions for you. So my first question is, I wrote it here. So you talked about optimizing the pipelines with the user feedback, but what is there like a practical way of getting the feedback from the user and put it back into your pipeline? So maybe do I use it as a memory with topic modeling? Like, can you maybe talk a little bit about the practical side
Yeah.
of things?
Yeah, there could be many applications for it. For example, one of the things can be memory, that's something people are working on. But for evaluation stack, what we are entirely focusing on is how we can effectively make use of this feedback from user to understand where the application is going wrong in most of the cases. Is it that is it going wrong when user is asking a particular type of query or a particular querying a particular type of database or something. So these can be hard to analyze. But we are trying to get through and have established some workflows there so that developers can just plug in their user feedback, get some analysis, go back and work on that particular error or pattern of error that users are seeing in production and make the whole experience better for them.
Nice, thank you. And the other question is about synthetic data generation. So if we know like these are big models and they are trained with a lot of data, and we are also using them to generate as far as I understand, we are generating test data using these models. But do you also do some sort of evaluation, or does it make sense to make some sort of evaluation with this generated data as well?
Yeah.
Because there can be a bias or any other problems that are very relevant to the generative AI world.
Yeah, that is true. That one of the biases most of the synthetic data generation has is factuality issues. For RAGAS, we are trying to generate synthetic data grounded on a given context or grounded on a given documents. So there, the challenges are very different from the general synthetic data, because imagine that you have a entire folder containing a lot of research papers or something. It is actually very hard for LLM to understand that this is a set of research papers. It just sees one particular context and frames a question based on that particular context, which is not what the user does most of the time. User mostly ask abstract questions rather than specific questions, since LLMs or AI systems generally does not have an abstract view of what your system is. Effectively conveying that into the LLM actually is the hard part there. And the entire goal of the synthetic data generation is to act as a copilot. Now, your job is to go and verify it. That is 10% of the time, so that it cannot be fully trusted, because again, there could be some biases, there could be some queries or questions that are even created by LLM that are not even worth to be in the test data set. So the developer's job is to just go and clear those out from the test data set so that it doesn't really mess up the whole thing.
All right, thank you so much. And thank you so much for the presentation. And people, if you have more questions, feel free to use the Q&A section, and Shahul can also answer your questions there with text. And with that, I think I can.
Can I add a question, maybe?
Oh, yeah.
So I wanted to take this opportunity to also ask one question. So as of now, Ragas use OpenAI, which could be expensive, as in my experience, because a lot of our clients have been using Ragas. So do you have plans to introduce maybe another cost-effective way of the test data generation? If yes.
Yeah. Yes, we do. Actually, we are reframing the whole test data generation thing. Actually, you can plug in open source LLMs with test data generation now, but the performance is very bad with that. Most of it. But with the newly coming reformat and version 3, we are expecting that it will be much better and programmable by the user. So yeah.
Cool. That sounds great. And would you be also introducing new metrics, or that would be too much to disclose?
Yes, we will be constantly adding new metrics for all type of task and or different data types. That will be the kind of vertical expansion that we do with the metrics, so that people are building RAG systems with different type of data and different type of kind of stuff. People are building multi-chat and everything. So extending support to all that becomes very important.
Cool. That sounds awesome. Thank you so much.
Thank you, Shahul, again. And yeah, feel free to ask your questions in the Q&A, and we can also try to answer them in the chat form. So Atita, without further ado, I think the stage is yours. You can start sharing your screen.
Thank you so much. I'll begin, and let me know if you can see my screen already.
I can see it.
Okay,
Nice.
perfect. Let me go into the slideshow mode. So thank you once again, Bilge, for the opportunity again to speak at this forum. And today my topic would be talking about RAG evaluation in action. So yes, we've seen like several articles. I think I'm more of a person who is driven by an actual real code or real things, so to say. So which is why I wanted to make sure that I take this opportunity to show the viewers and the attendees how RAG evaluation is done in practice. So yes, we would be building an actual RAG. I would see that if I can cover that in like 30 minutes. We would also be tackling a problem of the cold start that is generating an evaluation data set. Of course, we would be seeing like how this can be done with RAGAS and another method as well. And how can we go about optimizing the RAG pipeline with RAGAS. So before I go further, I forgot to introduce myself. So my name is Atita Arora, and I work as a solution architect at Qdrant. So that's a bit about me. I started majority of my time has been spent into the information retrieval space, been working in the space since 2008. And I'm an avid fan of open source. That's my LinkedIn QR in case if you're interested to connect with me. And I'm a contributor and consumer as well of a lot of open source packages as well. That's the company I work for, Qdrant. If you don't know, I mean, it's the most loved vector search database, and it's built for supporting the massive scale vector search technology for your generative AI applications. So it's focused on the performance, scalability, and resource optimization. It's quick and easy to start with, and it's open source. What could beat that? So it supports multiple quantization techniques and advanced filtering techniques as well, and also supports custom sharding if you're in the stage that you're building a RAG solution yourself. So we've recently launched a hybrid cloud as well to keep your data private and make it RAG ready as well. Plus, there are several other features that are coming by end of June. So they're going to be super RAG friendly as well. So keep an eye on that as well. So topic of the hour today, why RAG is such a rage and why you should be building one as well. So obviously, I think Shahul has already set up the stage that everyone seems to be building and RAG solution, and it's probably one of the easiest maybe ways to start contributing or bringing in generative AI into your organization. It saves time. It saves your cost as well, provided it's done correctly. And it also has multiple applications, as we've seen with a lot of our Qdrant customers as well. So you can build Copilot, you can build research assistant, customer bots, and whatnot. So I'm always amazed to see like what all our customers are building. I mean, it's kind of a RAG, but then it's obviously always something really fascinating. So it's very contextual as well, because you get to use your proprietary data along with the other techniques to interact with the LLM. It definitely enhances the engagement because customers get the responses and they're very contextual. So they get really motivated to ask more questions. So that basically impacts the enhancement of the engagement. So it's also multilingual because the embedding models that are coming right now are multilingual. So that basically breaks the barrier of the languages. And obviously they're very grounded, provided they've been tested correctly. So, I mean, even though saying that RAG is like the go-to solution to maybe implement the generative AI into your organization, definitely it comes along with some of the challenges as well. So as the name suggests, retrieval augmented generation, I tried to break down the challenges as well into the 3 different categories. So retrieval could have issues of the relevancy, typical issues like precision, recall. That is something that RAGAS measures pretty well as well. We would see that later. Along with that, lost in the middle problem as well, which was quite a rage, and which is probably one of the major reasons why chunking became so hot. Augmentation has its own challenges. So it's like making sure what kind of information to augment with the prompt, or sometimes, understanding the missing relationship between the context and the query that has been asked. Obviously, generation has different ballgame of challenges like hallucination. In simple words, the response when it is not correct is called like a hallucinated response, which cannot be confirmed with the provided context. Also, challenges with the biased answers and the tone of the answer as well, and obviously keeping sure that we're still maintaining the diversity of the responses. So if you want to follow more of such things, I've also written about this in one of the articles, which is linked in the footer of this slide as well. So I'm sure some of you must be wondering, like, I mean, RAG probably doesn't really gives all those challenges at all. So I'm sure you must have also seen like something like this pretty recently, which was floating around Twitter, LinkedIn, everywhere. So these challenges can really be bad for the company and for the organizations that are hosting those solutions. So I'm sure you must have seen like Google suggesting people to eat a small rock every day, or using glue to stick your cheese onto your pizza. Don't try that though, but that could be an impact of the untested or bad implementations of unevaluated RAG solution. So which is what we're recommending you not to do. And which is why, to reiterate what Shahul said earlier, so evaluation is something which is paramount. I mean, it's needed to ensure the correctness as well as the reliability, performance and improvement, contextual relevance, and the faithfulness of your solution, along with user satisfaction, making sure it complies to all the ethics that your solution is built for, and of course, confidence of the developers who have built that solution. So I'm sure RAGAS comes to the rescue, and Shahul has set the stage already. I've also tried to bifurcate the metrics as well in the different categories, like it provides you with the retrieval evaluation metrics like context precision, context recall, context relevancy. With responses, it has faithfulness and answer correctness, answer relevancy, answer semantic similarity as well. And apart from that, the notebook also uses the aspect critic, something that would highly go in the line of the compliance or the ethics that I was talking about in the previous slide. So something like ensuring that your response is not harmful, malicious, is coherent, is correct, is concise. So you can find out more on the RAGAS documentation as well. So obviously, how do you improve your RAG? There are multiple different techniques that I obviously always write about. So starting with something as simple as like ensuring that you spend some time on data cleaning, adding metadata to your content, because data is really the key here. And which is why it makes sense to invest some time onto understanding chunking, like what size of chunking might work for your implementation, trying out different embedding models to make sure that the embedding model that you're using for your implementation is also understanding the content of your like RAG. Experimenting with different retrieval window sizes. Like I would be showing that as well in the workshop today. So trying out providing less and more context chunks to the RAG pipeline, trying out different indexing algorithm, multi-indexing strategy as well, trying out sparse, dense, multimodal content that can be indexed, and of course, trying out different LLMs as well, and of course, re-ranking. So the idea that I'm going to be relying on today is how do we improve retrieval of our RAG, retrieval augmented generation. So why? Because I completely believe in the statement that if you can't retrieve it, you can't generate it. So retrieval is something I feel like one should really pay attention to when building a RAG solution. So first thing first, before I jump onto this notebook, I know people must be wondering that I was supposed to talk about the evaluation dataset building. So yes, the repo that I would be using today, I think Bilge is probably going to provide the links as well. It also has the notebook that you can use to look at different strategies of building your synthetic question answer set that could be used for the evaluation. So the notebook that I've shared is something that uses T5. Again, you don't spend money with that. That's why. And you can also use OpenAI, something very similar to what RAGAS does as well, by modifying the prompts. And of course, RAGAS provide that as well. Along with that, something recently I came up with, a tool called FiddleCube. I think I absolutely love it as well. Something very similar to what RAGAS does. As you can see, this is the snapshot of the questions generated by RAGAS. And you would see that the evolution type, for example, simple reasoning-based multi-context questions, this is something that one cannot really come up with manually. So this is the similar idea that FiddleCube also follows, and it generates questions on different topics as well. So I know I'm short of time, so I would not be going into that notebook, but that is something I'm leaving for the reference. So important links to follow is I would be using Qdrant Cloud today for this workshop. The code is available on this Git repo. Should you wish to find out more about Qdrant, you can follow the link. And I would be using embedding models from Mixed AI. Thanks to Bilge, she has helped me convert this entire notebook into the haystack format, which it was not earlier. So once again, shout out to her. And I would highly recommend you to try this notebook. Obviously, once you've taken the checkout, create a virtual environment, and this entire project is based out of Poetry. So you can install Poetry, and that should be it. That should get you up and running quickly. So let me quickly show you how the Qdrant Cloud looks like. I mean, as you can see, I'm also on the free cluster of this myself as well. And if you would wish to see, like, this is how my data set looks like in the index format. Apart from that, if people are kind of just curious about like how much data can I hold on Qdrant Cloud, so I'll show you like a small example. Like I have pretty many lot of data sets on cloud with the free tier as well. So I would highly recommend you to try this out as well. So this is the project that I would be using. As you can see that it's open source as well. So that's the notebook for the synthetic Q&A generation. And I would get into the notebook of this workshop. So one thing that I would like to also maybe notify here is that because we would be using multiple different things, for example, Qdrant URL or the API key that you would get when you are using Qdrant Cloud, you can put this in your environment file. So you can keep it as like .env plus your OpenAI API key. That is also going to be needed for this notebook as well. So you can store all of that in .env file. And as you can see, I've also added some of the artifacts here that I generated on the way to make sure that I don't have to run this in real time. Apart from that, I think I would quickly get into it. One of the things that I probably also would like to add here is that throughout this notebook, we are actually building a RAG on an actual use case on Qdrant's documentation. So there is a Hugging Face data set that is available to be used, which is also being used in the notebook itself. So you can see that also the pre-meditated evaluation data set, which is also sourced on Hugging Face, that you don't have to create one yourself. So this is a pretty good exercise if you want to try things out with RAGAS, Qdrant, or Haystack. Plus, we would be using embedding models from Mixed AI as well. And you can find out more by clicking on these respective links. So starting with, we would start with the relevant package import. We would do that. And of course, we're using the .env file, which is why we would import that as well. As you can see, I'm using OpenAI key here. So I would probably import that here. Along with that, the data set that I've mentioned, it's also available for the public use. So I'm going to be importing that. I need to obviously process my text to create chunks and pre-process it before putting it in my knowledge store, which is Qdrant, and which is why I'm going to be using, and throughout this notebook, I would be heavily using Haystack. So we would be creating the Haystack document out of this data set that we've had. So as you can see, it in total creates, it has 240 documents, which I would be splitting into different chunks. So just a quick note here, this is again optional feature, but if you would be interested to see how the test evaluation data set generation works with RAGAS, so this is something I've provided in here as well. So as you can see, I'm using only the first 10 documents of my data set because it's expensive. So you can see that it generates the question, context, ground truth, and all the evolution type and metadata related to the question generated as well, which is pretty handy if you don't have anything to begin with. Apart from that, I've also saved that in the data set that you can use offline as well, should you wish to. So this is, again, just a note, optional thing that you want to try out. Coming back to our data, so we would proceed with our document chunk processing. As of now, what I'm doing is that I'm creating the chunks of 512 length, and I'm also using the overlap of 50 for each of my chunks. So if you want, you can try using ChunkViz, which is a visualization tool for chunking, just to see how that would look like. So I would process them and I would split my data set. So as you can see, from 240 documents, I created 614 documents in total. Each of my document would look like something like this. It would have an ID, it would have content, which is an actual content of the document. This is probably one of the smallest example. Plus, we would also be storing in the meta content of each document, which has the source, like where, in case if you want to use like the references when we want to answer the questions, that you can find this information on this particular article. So this is something that it could be used for. So also for this notebook and in general, we are using FastEmbed for providing us with the seamless embedding creation throughout this and throughout your RAG application as well. This is something that I would highly recommend you to use. So this is a tool that natively supports embedding generation, which is native to, obviously, Qdrant. And if you wish to see like how many or what all models does it support, it's a good idea to try this out. You can see that you have plenty of embedding models that are supported with different dimensions as well. The one that I'm using right now is the default model, that is BGE, but there are like 21 models that are already supported by FastEmbed. So to process the chunks, we would be proceeding with different steps. So we would be, first of all, cleaning up the documents to make sure we remove extra spaces. We split the documents into the defined chunk size, and then we would be embedding the document chunk using FastEmbed Document Embedder. So all of this has been done with Haystack. So we define our embedding model here. I'm using Mixed-Bred AI model, the large model. Along with that, I define my text splitter. So I'm using splitting by word. There are different ways in which you could split the text as well. This, in my opinion, was the best one. You have paragraphs and you have sentences as well. This is something that you could try as well as part of the experiment. So once this has been done, what we do is that we create our Qdrant collection. And I'm calling this collection as this. It's a pretty big name, Qdrant Docs, RAGAS, Haystack, Mixed-Bred AI, and this is done for the live stream. So I try to keep it as grounded as possible to this event. So after that, we would use Haystack integration of Qdrant Document Store here. And we would create this collection. You can find out more about this. I have left all the links as well in my notebook. And along with that, we would just verify that the connection has been set, which obviously would. There are some general collection level operations, which are good to know. I had to use some of these because when I wanted to verify that if my collection is created with the so-called dimensions and so-called model, and I had to also delete my collection as well in between. So I'm leaving some of the additional operations here for the reference. And they're also good in case you're learning to use Haystack or Qdrant or RAGAS in principle. So we would then be processing the document chunks into Qdrant collection. We would be putting them in, and we would be using the Haystack pipeline for this. So we would add each of these components here, a cleaner, splitter, document embedder, and the writer in the sequence, and then we would be pushing them in. As you can see that it took me some time, and I pushed all the 614 documents just to verify, because I'm a finicky person. I verified that with document store count documents, making sure that I have indexed all my 614 chunks. So if you would change your document chunking strategy, like for example, different size or different overlap setting, this number is bound to change. So you would have to reindex the documents once again. So apart from that, we would be quickly checking that all our documents have been indexed properly. So we would try to run like a sample query as well. So like here, I have tried to look for like what is binary quantization. I've defined how many documents do I want to retrieve and what is my question. And here I get the sample response. So this is where I'm building my RAG pipeline without context. The reason why I did and included this into this notebook as well, because some people might just say that LLMs are smart now and they have been retrained to use all of this data. So no, it's not really the case. As you can see, the answer is pretty vague. When I looked for the binary quantization and using it directly to query my LLM, it is apparently referring to something page 45, which is nowhere to be found. Or when I was looking for reproducing the benchmarks for the open source vector databases, it also provided me something like source field, which is obviously non-existent, which is why what we do is that we add context from Qdrant in our RAG pipeline. And this is where I'm actually providing it. So as you can see, I'm using my same prompt, but I'm using the documents that have been retrieved from my query pipeline. So once I do that, I retrieve my binary quantization question again. I repeat the question, and this time it actually provides me with, this is where you would find it. So the source of the article, binary quantization markdown, this is where this article or this answer was prepared from. Similarly, when I looked for example, how to reproduce benchmarks, it provided me the Git repo. Again, this is from the documentation. This is the kind of answer that I was looking for. So I've also tried to include like the different retrieval window sizes from 3 and 5. As you can see, when you give more context or when you provide more chunks to the LLM, it definitely generates a more comprehensive response. This is very similar to what happened here as well. When we used the retrieval window size of 3, the answer was limited to defining the binary quantization. And along with when we went for like 5 chunks, it also added like what could be the impact of binary quantization on your RAG pipeline, for example. So that is the impact. So obviously we have to focus on the evaluation data set. So obviously RAGAS expect the data to come in different format altogether. So this is something that we would be generating on the go. So we would be using the question and answer as the ground truth and the questions for this data set generation. And we would be processing our questions and the context chunks through this subroutine called create eval dataset. And this is how I'm going to be generating the evaluation dataset. So as you can see, I'm experimenting with the different retrieval sizes. So I would generate 3 different sample datasets, one for retrieval window of 3, 4, and 5. And then I would be processing them through RAGAS to basically account for all the metrics that it supports through Haystack. So I'm using the RAGAS integration here, which is provided through Haystack. As you can see, there are plenty of metrics that can be evaluated for your RAG pipeline. This is where I'm basically processing that data set that I generated by processing my evaluation question and the response that has been generated by my RAG pipeline. So yes, this may, as of now, feel like a lot. And I would be evaluating for the precision, as you can see here, the context precision, context recall, context relevancy, utilization, faithfulness, answer relevancy, answer correctness, answer similarity. Along with that, I would also be checking for if my answer is not toxic. So this is probably one of the custom aspects of RAGAS where you can define your own aspect that matters for your RAG pipeline. So it makes sense to kind of provide something which is more of your use case dependent. So once we do that, I think I have added many things here to make it more visual in principle. That's the experiment with 4 chunks, that's experiment with 5 chunks, followed by that. You can see a lot of reds here because there are some metrics that are not supported by RAGAS anymore. That's what I got to know recently. So as you can see, I am evaluating for the first 10 questions from my evaluation data set as well. Once I've done that, I would be comparing all 3. And this is where I compare my evaluation of 512, the chunk size, and the retrieval window of 3, 4, and 5. I'm not changing the chunk size during this experimentation. So it seems like this is what it looks like. I mean, my answer relevancy evaluator did pretty well for retrieval window 3, 4, and 5, as you can see, RW_3, 4, and 5. So aspect critic 0, which means none of the answers generated in each of these experiments were toxic to the user. Context was absolutely a 99% or 100% utilized. And as you can see, the correctness metrics as well. Faithfulness was probably much better when I provided more context to my RAG, and precision was up to the point. The recall was obviously the better when I provided 4 chunks. And about the relevancy evaluator, before you ask me any questions, I just got to know that this is something which is not being currently worked on. But looking at this, it seems like the relevancy was much better when provided less context. So it seems like everything seems to be doing pretty well, except the part that was dealing with the retrieval of the information from the vector database. So which is why my another set of experiment that I did was with the re-ranking, and which is why we wanted to improve like on the relevancy and recall metrics, and also the faithfulness, of course, because it's 0.8 is what we see at the max. So what I did next was I added another layer into my query pipeline. And as you can see, apart from query embedding, retrieving, and I added another component to do the re-ranking of the documents as well. So let's see when we try things out with re-ranker. Obviously, as you can see, I repeated like the question, what is the purpose of create payload index async? So when I did that without any re-ranking, I saw that it was giving me the points as the first response and multiple partition as the second response. When I applied the re-ranking, rather, just to let you know, this multiple partition was rather more relevant to this option. So I saw that this was being pushed in top of the results. So obviously this is regardless of what we've seen so far. So providing this component and adding this into our pipeline into the querying would make more difference. So I had to repeat like my RAG pipeline again to add the re-ranking step here. And I repeated the same experiment where I'm retrieving 3 chunks and re-ranking the first 2. I am then retrieving the 4 chunks and 5 chunks respectively. And I know this is kind of too small, which is why I'm probably going to go back to my deck once again. And so just to kind of recap, I know we're short of time as well, and I want to leave some time for the questions as well. So what we did was we built an iRAG, and that's the example that you can refer back to after this presentation, after this live stream. So we built an iRAG using Qdrant Cloud, Fast Embed, Haystack. Embedding model we've used from Mixed-Bread AI and OpenAI. And we touched on different ways to improve RAG. We evaluated our RAG using RAGAS with varying size of the retrieval window, 3, 4, and 5, as I said before. So we discovered that everything was fine, except the faithfulness could be improved because it was not a perfect one. The context recall could also be improved. This is the metrics that I'm talking about here. So it is also doing pretty well, but it could be improved further, of course. Perfect 1 is the limit. And answer relevancy definitely is not doing that great as well. So after we applied re-ranking, we saw that the other metrics nearly stayed the same. And we saw that there was a big boost, as you can see, re-ranking with the chunk size of 3, re-ranking of chunk size 4, re-ranking of chunk size 5, the retrieval window of 5. So as we can see that it had a pretty major impact on the re-ranking step with 3 chunks. The precision evaluator also was doing already pretty well. The recall also improved, but it improved for the chunk size or the re-ranking when we applied it with the retrieval window of 4 and 5. And relevancy, as you can see, also improved. So the idea here was that we wanted to see like what steps would make more sense to apply or experiment with. Obviously, there are many more methodologies as we discussed also during our presentation. You can try this out with different chunk sizes, different chunk overlap setting, different embedding models, different retrieval strategies as well. If you would follow the same Git repo, you would see that I've also experimented with sparse and dense vector, that is the hybrid combination. I've also tried things out with different LLMs as well. I have also tried like different chunk sizes as well. So this is something that you can as well try. And we can also try the things out in another different way, as I said before, with different LLMs, as Shahul suggested as well. So this is all which has been highly recommended. This is like one part of the experiment that I showed. And of course, we would love to for you to contribute your experiments or any suggestions you might have that we should try it out. So I guess that is it for my presentation. If you want to try out Qdrant Cloud, that's the QR code you can scan. You would get free forever 1 GB cluster. That's the same one I am on as well. And if you have any questions, don't hesitate to reach out on info@qdrant.com. Thank you.
Thank you, Atita. That was a lot of information about evaluation, and I think that was very useful. We have some questions in the chat, so I think you kind of answered some of those, but let me ask them again. The first question is, so for getting the better performance of a RAG pipeline, is it a good understanding that we have to take some time and experiment with different permutations and combinations of embedding models, chunk size, LLMs, etc.?
Yeah, that is what I reiterated as well on my last slide as well, just to make sure that we are on the same page. Yes, there is no rule of thumb here, and every use case is different, so it does make sense to try out different settings or whatever might work for you. And of course, you can use RAGAS kind of in the iterative way. This is the iterative process. I mean, that's why. So yes, that understanding is correct.
Yes. The other question is how indexing is important and which algorithm is better for indexing in general?
So as of now, what I would say is that the only indexing algorithm that I've tried is HNSW. I mean, it does make sense to try things out in different ways. So for example, again, not supported by Qdrant, but for some of the use cases we've seen, like it makes sense to try out, for example, a knowledge graph way as well. Or if you're combining strategies, you could try out the normal lexical search way as well. Plus, it would make sense to try out, for example, if again, this is also dependent a little bit on the kind of queries that you are prospecting for your use case as well. So like, for example, we also built like a use case RAG solution with the sparse vectors and dense vectors combined. So there was a pretty neat metrics that we got with that as well, because we combined our nature of queries, which involved like exact matches, as well as the semantic retrieval as well. So it would make sense to obviously decide that based on whatever use case that you have at hand, and also the nature of queries that you're prospecting for your use case.
Thank you for this answer. Next question is, this is about the recommend. In my experience, semantic chunking gives better results for splitting in input documents. What do you think about that?
Did you say semantic chunking?
Yes.
I'm afraid I'm not aware of that.
Or maybe that might be a question for you later on if they want to.
For sure. For sure.
Yes.
I think that's a good point. That's a learning for me. I mean, I can find out more about this. I've definitely heard the term. I think now it rings a bell. But I mean, frankly, I haven't tried it as of yet. But I can try it out, and I can post this when there would be a YouTube for this live stream that will be posted. I would leave my comments there.
Yeah. All right. And the last question that we have is, can I use another model than OpenAI? And if yes, then which one?
Yes, of course. It would make sense. I think you would find a couple of different examples using things from Mistral. That's in a different folder altogether. But we've seen that overall, the improvement in the metrics have seen in the RAG basically pipeline. The ones that are using OpenAI have shown pretty good responses. So, but then we do have like solutions here in this Git repo that use Mistral as well. So that could be used for the reference as well. And plus, I think there are multiple other models as well. Like you can try Llama 3 as well and whatnot. I mean, I don't need to prescribe. I mean, obviously you can use.
All right. Maybe another question. The same audience told that Gemini. Have you used Gemini models and tested them maybe?
That's actually a good point. We have tried Gemini. Yes, but we haven't compared it with OpenAI. So yes, I have created some content with Gemini as well, but I do not have the kind of the relative metric
All right.
for the reference.
All right. We have one last question. I'll ask this one, and then we can maybe close this session. Have you already tried to build a knowledge graph for index, and what are the difficulties?
So I think that's an interesting question, and not in the context of Qdrant, but my background is I started my information retrieval career with knowledge graphs, and this is something that I'm talking about from the year of 2007. We had very limited technology back then. So one of the things that I have felt when using knowledge graph is that it doesn't suit every use case, number one. I mean, you need to have and you need to spend a lot of time building those knowledge graphs as well, because you need a lot of context of the domain. I mean, it's not as simple as building a vector index. So, which is why, if your domain requires, I understand that there are certain domains like medicines, like finances, like insurance, where you could be benefited by using knowledge graphs, but it's not something that I would urge users to start off with. I hope that answers the question.
I hope so too, because I also know that knowledge graphs are not very easy to start with. All right. I see a lot of questions coming up, but we are out of time right now. Feel free to reach out to the speakers. They already shared their information with you. And this recording will be available on our YouTube channel, haystack_AI. I will be also sending the links of the recording and the material to you after the live stream. Thanks everyone for joining. I think that's a wrap. And have a nice rest of your day or evening. Bye, everybody.